For this project, we needed to observe uniform and accelerated motion in a unique way that may be present in our everyday lives without us even knowing. In order to complete this, we decided to observe a ceiling fan and the way it connects to the topics we are learning in Physics 2204. Before starting our videos, we placed a bright pink note card onto one of the wings of the fans and decided our starting point of the labeled wing, so in our calculations we could count the number of rotations by seeing how many times in each video the labeled wing got back to its starting point. When we pulled the cord for the fan started to move and slowly got faster and faster until the fan reached its top velocity moments after. After that point, the fan did not accelerate anymore. With this event, we could observe our accelerated circular motion. Once the fan was at its top velocity, we observed the uniform circular motion of the fan because at its top velocity it cannot possibly get any faster. To help ensure that our data was at the best quality, we took multiple videos of the accelerated and uniform circular motion until we got the most accurate version of the task that we could. For each video, we recorded for exactly 10 seconds to make calculations and graphing easier for later. After editing the videos into slow motion, they were each 21 seconds. For the purpose of our graphs and calculations, we used the time of 10 seconds from the original video.
For the accelerated motion, F is frequency. The first one is 0 revolutions per second and the second one is 2. Omega represents angular velocity. The first one is 0 radians per second and the second one is 13. Time is 10 seconds and the radius is 0.37 meters. The angular acceleration is 1.3 meters per second squared. The tangential acceleration is 0.48 meters per second squared. And the centripetal acceleration is 63 meters per second squared. The total acceleration is 63 meters per second squared. There you have the graph for the accelerated motion. It is a straight diagonal line because the velocity is increasing at a constant rate. For the uniform motion, the frequency is 4.5 revolutions per second. The time is still 10 seconds. The radius is still 0.37 meters. Omega this time equals 28 radians per second. And the centripetal acceleration is 2.9 times 10 to the power of 2 meters per second squared. There we have the graph for uniform motion. It is a straight horizontal line because the magnitude of velocity is constant and does not change.